So now let's talk about inverse cosine. Again, I wish I could say that you have the same locations where inverse sine and inverse cosine are going to exist, but they're not. And the reason why is I'm going to look at the graph to explain why. So again, you remember back from Unit 2, we spent a lot of time graphing cosine of x. So remember the parent function, instead of starting at the baseline, started at the maximum. Then it was a baseline, minimum at -1, baseline, maximum. So one's full cycle from 0 to 2 pi would look something like this. If I graph this from -2 pi to 0, looking at another cycle, this is what your graph of cosine of x would look like from -2 pi to 2 pi. Again, just like for sine of x, it's a function, but notice it's going to fail your horizontal line test. So what happens is, if you look from -pi/2 to pi/2, you can't use the same restrictions for sine as you do for cosine, because notice for cosine, this graph is still not 1-to-1 from -pi/2 to pi/2. So the restriction we're going to use, actually, this is your pi/2, this is your pi, is going to go from 0 to pi. Notice from 0 to pi, cosine of x is a 1-to-1 function. So that is where we're going to restrict cosine of x to force it to be a 1-to-1 function. So here's 0, 1. There's your pi/2, 0. There's your pi. So there's the cosine of x. Remember, cosine of x has a domain of all real numbers. The range goes from -1 to 1. So to force it to be a 1-to-1 function, we use that restriction from 0 to pi. So then to take a look at the graph of your inverse cosine of x, you have the point 0, 1, pi/2, 0, pi -1. So remember, I will switch the x and the y coordinates to find the points on the inverse. So 0, 1 will go to 1, 0. Pi/2, 0 will go to 0, pi/2. Pi -1 will go to -1 pi. So that's what your graph of the inverse cosine is going to look like. Remember, the domain and range flip-flop, looking at your graph, the domain is now going to be -1 to 1, the same as the range for cosine of x. The range is going to be the same as the restricted domain, which goes from 0 to pi. So the theorem composition for this to be equal x, so in other words, when you take cosine and do a composition with inverse cosine, it has to be equal to x only if x is between whatever the restricted domain is, whatever the domain is for inverse cosine, which is between -1 and 1. So this value, this number, has to be between -1 and 1 in order for it just to be x, for that cancellation to occur. Again, if you go the other way, if you do the inverse cosine and you do a composition with x, it's only equal to x if x is between whatever the restricted domain is for this inner function, which in this case is going to be from 0 to pi. We'll take a look at problems in a few minutes where you will not be able to use this theorem. You cannot use this theorem all the time for your composition for inverse trig. Remember, the other notation, just like for inverse sine, inverse cosine, you may also see the arc cosine of x. It's the same, means the same thing. They're both inverse, it's just different notation. And remember, this means x equals cosine y, where again, your domain, your x values have to fall between -1 and 1, and the y values fall between 0 and pi, which is your range. So how this relates to the unit circle. Remember, for inverse cosine, we're only going to be looking from 0 to pi. So we're only looking in quadrants 1 and quadrant 2. Quadrant 3 and quadrant 4 are dead for inverse cosine. Again, it does not exist in quadrants 3 and 4 because of the restrictions we placed on cosine of x in order to make the function a one-to-one function. So remember, inverse sine, you're in 1 and 4. Inverse cosine, you're in 1 and 2. So inverse cosine of 1, again, just like for inverse sine, the question you're asking yourself, what angle? And again, you can only be in quadrants 1 and 2, has a cosine value of 1. Remember, cosine is now your x-coordinates. So you're looking at the x-coordinates from the unit circle. So remember, right here on your positive x-axis, you have the ordered pair 1, 0. So your x-coordinate's positive 1, so inverse cosine of 1 is just going to be 0 degrees or 0 radians. And again, that's a quadrantal. You're right there on the axis. Arc cosine square root 3 over 2. Again, this is positive, so you know we're in quadrant 1. So again, the angle where you have an x-coordinate of square root 3 over 2 is pi over 6. And again, this is in quadrant 1. So both inverse sine and inverse cosine are in quadrant 1. Inverse cosine square root 2 over 2. Again, the angle in quadrant 1, because this is positive, that has an x-coordinate of positive square root 2 over 2 is going to be pi over 4. Arc cosine of a half. Again, you're looking for the angle in quadrant 1 that has an x-coordinate of a half. So the angle that has your x-coordinate of a half is going to be at pi over 3. So that takes care of all your inverse cosine values for quadrant 1. Now let's move on into the where inverse cosine is equal to 0. Again, on your positive y-axis, you have this ordered pair 0, 1. So here's where your x-coordinate is equal to 0. So this angle here is going to be pi over 2. And again, that's a quadrantal. Now we're going to be moving into quadrant 2 because that's where cosine is negative. Remember, all students take calculus. Cosine is negative in quadrant 2. So you're looking for the angle in quadrant 2 that has your x-coordinate of negative 1/2. So that's going to be at 2 pi over 3. At 2 pi over 3 from your unit circle, your x-coordinate is negative 1/2. So this is quadrant 2. Inverse cosine negative. Again, you have to be in quadrant 2. The angle in quadrant 2 that has your x-coordinate negative square root 2 over 2 is at 3 pi over 4. And then inverse cosine of negative square root 3 over 2, that's going to be 5 pi over 6. Again, that's quadrant 2. Inverse cosine negative 1, you have your ordered pair here on the negative side of the x-axis at negative 1, 0. So your x-coordinate at pi is negative 1. So then your inverse cosine of negative 1 is pi. Just like the unit circle, you have to memorize these values.